Okay, folks, welcome back to 4-4 connective tissue. Now, connective tissue is probably one of the hardest tissues to study, probably. I'm not sure. It depends on how you learn. So I got this video. It's an overview of all of connective tissue. Pretty darn good video, pretty comprehensive. But then we will turn around and go back through some of the images and talk to them. All right, so here you go.
Connective tissue is diverse, abundant, and widely distributed through the body. Its primary functions include structural support, binding structures together, fat storage, exchange of nutrients and metabolic waste, and defense and protection. All connective tissues share three basic components: cells, protein fibers, and ground substance. Together, the protein fibers and ground substance form the extracellular matrix. The proportions of these components, in addition to different cells and protein fibers, help define the various categories of connective tissue. In the adult, connective tissue can be divided into three broad categories: connective tissue proper, supporting connective tissue, and fluid connective tissue. There are two basic subcategories of connective tissue proper: loose connective tissue and dense connective tissue. Loose connective tissue has abundant ground substance with scattered cells and loosely arranged protein fibers. By comparison, dense connective tissue has abundant, tightly packed fibers but relatively few cells and little ground substance. Loose connective tissue can be subdivided into areolar, adipose, and reticular connective tissue. Areolar connective tissue is found in the subcutaneous layer and around organs. It has a gel-like ground substance, numerous blood vessels, and scattered cells known as fibroblasts. Adipose connective tissue is found in subcutaneous tissue and around some organs. It is composed of closely packed adipocytes or fat cells. Reticular connective tissue forms the stroma, a connective tissue framework, of lymph nodes, the spleen, the thymus, and bone marrow. It is composed of a network of branched collagen fibers, known as reticular fibers, with scattered fibroblasts and leukocytes, or white blood cells, embedded in a gel-like ground substance. Dense connective tissue can be subdivided into dense regular, dense irregular, and elastic connective tissue. Dense regular connective tissue forms tendons and most ligaments. It is composed of densely packed parallel collagen fibers with fibroblasts between the layers. There is little ground substance. Dense, irregular connective tissue is found in the dermis, periosteum and perichondrium, and the capsule of organs. This type of connective tissue is composed predominantly of randomly arranged collagen fibers with fibroblasts interspersed. There is more ground substance than found in dense, regular connective tissue. Elastic tissue is found in the walls of elastic arteries, the trachea and bronchi, and the vocal cords. This type of connective tissue is composed predominantly of branching elastic fibers, with fibroblasts in some spaces between the fibers. Elastic fibers, formed by the protein elastin, stretch under tension and then return to their original shape when tension is released. Supporting connective tissue can be subdivided into cartilage and bone. Cartilage has a semi-solid extracellular matrix that allows flexibility, whereas the solid matrix of bone is more rigid and provides greater support. There are three types of cartilage: hyaline cartilage, elastic cartilage, and fibrocartilage. Hyaline cartilage is the most common type. It is found on the articular surfaces of synovial joints. It also forms the cartilage of the larynx, trachea, and nose. Chondrocytes, or mature cartilage cells, are found within small spaces called lacunae. that are scattered irregularly in the extracellular matrix. Collagen fibrils are present within the matrix but not visible in the light microscope. A perichondrium, a dense irregular connective tissue sheath, overlies most cartilage. Elastic cartilage is found in the external ear and in the epiglottis. It contains abundant elastic fibers, which form a web-like mesh around lacunae that contain chondrocytes. Like hyaline cartilage, elastic cartilage usually has a perichondrium. Fibrocartilage is found in intervertebral discs, the pubic symphysis, and the menisci of the knee joint. It contains numerous irregular bundles of collagen fibers. The sparse ground substance contains chondrocytes within lacunae that are frequently arranged in parallel rows. Unlike hyaline and elastic cartilage, fibrocartilage does not have a perichondrium. There are two forms of bone or osseous connective tissue: compact bone and spongy bone. Compact bone usually forms the hard outer shell of bones. Concentric rings of bone, called lamellae, form cylindrical structures known as osteons. Each osteon has a central canal that connects to a network of tiny branching passageways called canaliculi. The central canal and canaliculi contain blood vessels. Osteocytes, or mature bone cells, occupy lacunae, small spaces, between neighboring lamellae. Spongy bone, also known as cancellous bone, usually forms inside of bones. It does not contain osteons. Slender bony plates, called trabeculae, form a bony network. The spaces between trabeculae contain bone marrow and blood vessels. Osteocytes are scattered throughout the trabeculae. The combination of compact and spongy bone allows bones to be both strong and lightweight. Fluid connective tissue is represented by blood. The formed elements of blood, specifically its cells and cell fragments, include erythrocytes, or red blood cells, leukocytes, or white blood cells, and platelets. The watery ground substance of blood contains dissolved protein fibers.
Okay, folks, so let's walk through each one of these individual slides and talk about that. So you need to memorize this. You're going to do it in lab as well, so you're going to get this twice. Break down connective tissue into connective tissue proper and supporting connective tissue and fluid connective tissue. Those are the three main categories of connective tissue breakdown. Now let's just go one at a time. Connective tissue proper can be broken down into loose and dense. Under loose, you have areolar, adipose, and reticular. Under dense, you have dense regular, dense irregular, and elastic. Now we're going to look at each one of these separately, but I want to show you the classification scheme first. Supporting connective tissue has two different types, cartilage and bone. But there's three types of cartilage. There's hyaline cartilage, probably the most abundant, elastic cartilage like your ear, and fibrocartilage, your intervertebral discs and pubic symphysis. Two types of bone, compact bone, which has those osteons that you heard her talk about, and spongy bone or cancellous bone, which makes the bone lighter because it's not as, quote, compact. And then luckily for us, the only example of fluid connective tissue is blood. I say luckily because there's a lot of subcategories here. So let's start talking about each one of these individual subcategories. Now this picture is not in your book. It comes from a different book. It's the same breakdown, but what I wanted to show you here was this. Mesenchyme is the embryonic origin of connective tissue. And this mucous connective tissue is a little bit unique. You find it in the umbilical cord, and as a nurse, especially if you're OBGYN, you might draw blood from an umbilical artery or an umbilical vein, and you'll get what's in the umbilical cord called Wharton's jelly. What it is it's mucous connective tissue. This is bad for the lab. It coagulates the tube of blood, and the lab can't do anything with it. So be aware that when you're drawing blood from an umbilical cord, you could pick up Wharton's jelly. You might want to draw a couple tubes or 2 or 3 tubes in case one of them is bad. You can see the connective tissue proper here, and we broke it down like we did before. Oh, but we did a little bit different here though. Under the dense regular and dense irregular connective tissue, it actually breaks it further. It breaks it into dense regular collagenous and dense regular elastic. Likewise, dense irregular collagenous and dense irregular elastic. Under the supporting connective tissue, you have cartilage and bone, the 3 types of cartilage and the 2 types of bone. And under fluid connective tissue, you have blood, but it breaks down the cells inside the blood. So you can see it's the same classification system. Again, same classification system, but a slightly different picture. The reason why I like this picture, because it tells you what cells make it up. So a fibroblast makes connective tissue proper, a chondroblast makes cartilage, an osteoblast makes bone, and blast cells actually make blood, but there's different blast cells. Like there's normal blast, which makes a red blood cell, and there's a myeloblast, which makes granulocytes, and there's a lymphoblast, which makes lymphocytes, and that's about it. So there are blast cells in hematopoietic stem cells, and they make blood. All right, so that's why I like this picture, because it shows you the cells that make it. Now let me just tell you about this. Connective tissue is made of cells. You can see the cells right here, and they're made of ground substance. Well, I should say this. They're made of a matrix, and the matrix has a ground substance and a protein in it. So ground substance and protein. Now the ground substance is usually glycosaminoglycans, and we call it GAGs, glycosaminoglycans. And you've probably heard of chondroitin sulfate and glucosamine. So a couple examples of glycosaminoglycans is chondroitin sulfate and glucosamine. You might have heard of them with pills for your joints, like osteobiflex. Well, just think what your joints are. They're hyaline cartilage. Of course they need chondroitin sulfate and glucosamine because they're connective tissue. And then the fibers come in 3 flavors. There are reticulin, elastin, and the most abundant is collagen. Now really the only difference between all of these connective tissues is the ratio of ground substance to fibers and the ratios of the fibers within the matrix. So sometimes you have high reticulin, sometimes you have low reticulin and high elastin, and then usually you have high collagen and low reticulin and low elastin, because collagen is the primary fiber in connective tissue. So really that's the only difference between all these connective tissues is, well, there's 2 differences. The cells that make it up and the ratios of the fibers in the matrix and the ratios of fibers to ground substance. That's the difference. Okay, so let's start looking at each one of these individually. This is areolar connective tissue. It's a great one to look at because it's like a collage. It's your quintessential connective tissue. It has collagen, it has elastin, it has reticulin, it has fibroblast, it has other white blood cells and macrophages. It's just a quintessential connective tissue. So you look at it and you see a lot of characteristics. You can see the reticulin, or they call them reticular fibers. You can see, you can see the elastic fibers. Don't tell me they left out the most important one. No, they didn't. Collagen fibers. Those are the 3 fibers. You can see a fibroblast. You can see some white blood cells in here. So this is the classical connective tissue picture. All right, the Wharton's jelly we already talked about. It's mucous connective tissue embryonically. That's Wharton's jelly. We just talked about that. You got to be careful when you're drawing blood from an umbilical cord because you might pick up Wharton's jelly. Okay, connective tissue proper. First, under connective tissue proper, we have loose connective tissue. Under loose connective tissue, we have areolar, we have adipose, which is just fat, and we have reticular connective tissue. Areolar is found everywhere. All right, and first of all, it's found in the dermis of the skin. It's found found in basement membrane. It's found around joints, in and around joints. It's found between muscles as fascia or fascia. It's just found everywhere. Loose connective, areolar connective tissue is found all over the place. All right, adipose tissue. Well, depending on what gender you are, you might store this in different places. Men and women store adipose tissue slightly differently, which is what gives us our body shape. But it's also in the hypodermis, or the subcutaneous layer of your skin. Hypodermis is also called subcu, or subcutaneous. It's abbreviated subcu. Subcutaneous. It's found there. And always, 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 it's found around your kidney. It doesn't matter if you're Michael Jordan and have 2% body fat, you still have fat around your kidneys. And if you feed birds and you've ever bought suet, and really what it is fat with seeds embedded into it. Well, what suet really is, the fat part of suet, is renal fat, the fat around kidneys. That's what it is. And then the last loose connective tissue is reticular connective tissue. It's the framework of several organs, like your spleen and your liver. So this becomes the framework, and they do stain darkly like you see here. That's reticular connective tissue. Dense connective tissue is your tendons and ligaments, and that's specifically your dense regular. But you also have some dense irregular. And what is the dense irregular? What it is, it's found in the skin. By the way, you're going to say, you told me that areolar was found in the skin. That's correct. Areolar is found up in the top part of the dermis, and dense irregular is found in the bottom part of the dermis. So both connective tissues are found in the dermis. Dense irregular. So areolar is the top part of the dermis, what we call the papillary layer, and dense irregular is the bottom part of the dermis, and we call it the reticular layer. And yes, I know that's confusing. We call the bottom part of the dermis the reticular layer, and it's not reticular connective tissue, it's dense irregular connective tissue. It's also part of the periosteum and perichondrium. These line the outside of bones and cartilage. So you're going to say cartilage is a connective tissue. You mean it's lined by another connective tissue? The answer is yep. Dense irregular connective tissue is the capsules for many things, for organs and bone and cartilage, etc. So this is quite ubiquitous. And then lastly, I have here for the dense connective tissue, I have elastic tissue. And this is found in between now when I say it's found in between vertebrae, not the disc. The disc is fibrocartilage. But it's found between vertebrae here, where when you bend over or stand up, you have to stretch. Well, when you bend over, you have to stretch this space between the vertebrae. Elastic connective tissue is in there. All right, so right here, that's elastic connective tissue, because when you bend over, that stretches. And elastic connective tissue has a lot of elastin in it, and it's flexible. Fluid connective tissue is blood. We have the cells of blood, or the formed elements. We have erythrocytes, which are red blood cells. We have leukocytes, which are white blood cells. And we have thrombocytes, which are platelets. Thrombocytes. Now, the reason it's not written there for you is because some people don't call platelets thrombocytes, mainly because they're not full cells. They're cell fragments. They pinch off of a cell called a megakaryocyte. But a lot of people still use the word thrombocyte for platelets. So erythrocytes, leukocytes, and thrombocytes are the cells of blood. Now we have supporting connective tissue, bone and cartilage. We have 3 types of cartilage and 2 types of bone. For bone, we have compact and spongy. For cartilage, we have hyaline, elastic, and fibrocartilage. Hyaline, elastic, and fibrocartilage. Let's see which one we do first. We're doing cartilage first. Okay, this is a supporting connective tissue that is made by chondroblast. Chondroblast, after the cartilage is made, matures into a chondrocyte. This is a chondrocyte. Okay, these are chondrocytes. They exist inside a cavity called a lacunae. So this cavity right here that the chondrocyte exists in is called a lacunae. And what you're going to find later with bone is the osteocytes exist inside a cavity called a lacunae. So these chondrocytes exist inside a cavity called a lacunae. The cells that make the cartilage are called chondroblasts. That's a chondroblast and that's a chondroblast. Now remember how I told you dense irregular connective tissue surrounds cartilage? This is dense irregular connective tissue, and that's made by fibroblast. So this would be a fibroblast here, and that's a fibroblast. And dense irregular connective tissue makes what we call the perichondrium. We also have a periosteum around bones, and dense irregular connective tissue makes up that periosteum. So that's cartilage and how we make it with chondroblasts. Here are the 3 types of cartilage. Hyaline cartilage is probably the most abundant. Matter of fact, I'm sure it's the most abundant. It's found in your joints. That means it lines the end of your bones. Where 2 bones come together is called a joint. It's found in the trachea. And I mean, it's found all over the place, but that's 2 main places it's found. So this is hyaline cartilage. Elastic cartilage, just think about your ear. All right, think about ear when you think elastic cartilage. And fibrocartilage is found 2 places. It's your intervertebral discs. That intervertebral disc is fibrocartilage. And it's your pubic symphysis. Pubic symphysis. Now, there's one other thing. Well, it's kind of major, actually. I might as well put it. The menisci of your knee. Everyone's heard of their lateral and medial meniscus. You've probably almost always heard of your medial meniscus. Because when someone hurts their knee joint, they typically tear what we call the terrible triad or O'Donoghue's triad. And that terrible triad is the medial collateral ligament, the anterior cruciate ligament, and the medial meniscus. So a lot of people have heard of the medial meniscus, and the medial meniscus is made of fibrocartilage. All right, another supporting connective tissue is bone. 2 types of bone. Compact bone that you see here, all of this is compact bone, all of it. Matter of fact, this circular structure is called an osteon. Here's half of another osteon. These are osteons. This is circumferential lamella out here. It's still compact bone. It's just circumferential lamella. Now look at this. The fibrous layer of my periosteum is dense irregular connective tissue. And the cellular layer of my periosteum contains the cells that make bone. And we haven't gone into this yet, but one of them is an osteoblast. So the cellular layer will contain cells like osteoblasts and osteogenic cells, which we'll talk about later. So that's dense bone. There is spongy bone. I'll show you a picture of spongy bone in lab because you'll have to be able to recognize it. It's in the epiphyses, the ends of your bones, and in the medullary cavity, which is what you would probably right now call bone marrow. But bone marrow is actually a tissue. The medullary cavity is the space in which the tissue exists. So the bone marrow cavity is made of spongy bone. All right, this is cartilage and bone comparison for you. And that's it. I'll see you in the next primary tissue.